Hi there, this is Carl Irwin with another Blender tutorial, and this is supposed to be, there was supposed to be 7 episodes to my PBR shader series that I just completed, but this is going to be a bonus tutorial. It's kind of a Christmas present here, because what I'm going to do is I'm going to show you how to use a file that has pre-made materials and node groups using the techniques that we've already discussed in this series, and I'm making the file available with plug-and-play node groups so that you can start playing around with some of these concepts right away without having to build these materials on your own. This tutorial is going to be dedicated to this file that I'm sharing, and when you open up the file, and the file download will be in the description for this video, so you can go download that as soon as you're done watching this, or maybe you want to pause now and go grab it so you can kind of follow along. When you open up the file, and the file will be called Viewport PBR nodes.blend, you'll see this scene here with a few instructions. It links back to, or rather gives you a shortened link to the video tutorial series that you're watching right now, and it will show the entire series, all 8 episodes, so you can see those initial tutorials where we discuss the methods by which we create box maps and build these node groups. Now, this file is only going to include one material that's packed into it for the scene. So in terms of using your other box map materials, I leave that up to you to go build those on your own. So you're going to want to follow those initial tutorials, the first couple there that discuss the formation of box maps, diffuse box map and reflection box map from equirectangular projections. So you'll have to go get some equirectangular projections. There's many free and available that are open source to edit online, or you can create some too using some simple cell phone software that you can get from the various app stores out there to generate 360 box maps, or rather 360 equirectangular projections in pretty much any environment. But anyway, you're going to need to build those yourself. I'm giving you the kind of that default one that we've been using all along, that construction scene setup that we've had in our tutorial. So that is packed into this file. You'll see this link for the tutorial series, and then it explains here the tutorial specific to this file is listed as Tutorial8, which is the tutorial you're watching right now. Okay, and also it explains that the test model can be found in the material scene of this file, and if you go up here and you look at the scenes, we have the information scene, which we're on right now, and if you go to the material scene, you will see the test model, which is Suzanne, the same Suzanne that we've been using all along, with a few materials that are already, a few node group materials that are already applied. And if you look down here, you see this fancy schmancy, highly organized set of node groups down here. So I've organized it, I've color-coded also these different node groups, at least in the main file, so you can reference them very easily. Now when you go to append or link into these node groups, you're not going to see the colors and everything quite as you see it here. It won't quite come out the same way. At least I don't think it will. So this is more just for organization if you're going to kind of play around with these node groups inside of this particular scene. There are ways to import these. We'll talk about that in a moment, but first I just want to show you a few upgrades that I've made to these node groups, and one new concept in particular that I've added to this file since the tutorial 7, which I put out just a few days ago. Very quickly, here are the node groups that we have. I have a node group for diffuse lighting. I have a node group for the reflection. I have a node group for refraction. I have a node group for car paint. This was refined from one of those first tutorials that you saw in the series. I have a node group for shadow mask. You can see that I'm going through the diffuse to the shadow mask. I have a node group for specularity, and I have a node group for subsurface material. I have a node group in here for color adjustment, and this merely has a hue and saturation and a color curve in it. So you can kind of, one-stop shop, plug this in. Say you want to have a particular kind of reflective color, or you want to change that car paint color, you can use this kind of an adjustment node, just putting two simple nodes together. And then I also added in this node group, which is called an AO mask, ambient occlusion mask. And you'll notice that it has two spots. It has one for the ambient occlusion map, and then it has one for the material input. Okay, let me just take a quick look at this for you so you can see what I've done. This is very simple. All it is it's a shadow curve. So we're taking the material input, and it takes the whites way down, much like we do with the shadow mask, and then this is mixed in with the original input, and it applies the ambient occlusion mask into the factor, and then that gives us our output. So it's essentially the same thing that we were doing in tutorial number 7 with ambient occlusion, but it's just set up ahead of time inside of its own node group. Okay. Now I want to explain this here. I talked about my node groups, but you'll notice that for each node group I actually have two node groups. So we have a diffuse lighting node group, which resembles the diffuse lighting node group that we created in the series, but I have a secondary one down here, and it's called diffuse lighting normal. Now what this is it's the same setup, but it has a normal input. And the idea is that if you have a normal map or a material, a shadeless material that has a normal texture in it, you could put that normal into this node group, and you could apply that normal such that it will affect the diffuse lighting, and it will affect the shadow lighting from the OpenGL light source that you have in there. It will affect the specularity, and it would affect all of those things related to a subsurface material as well. So now I tried to find a way to generate a node group that would have a normal input that you could either use or not use. I couldn't find an easy way to do that, so really the quickest way around was just to create a duplicate for each one of these node groups that just has a normal input. So if you're using normals, a normal map, you can use this node group. If you're not, there's no need to use this one. In fact, it won't even work unless you have a normal input on it. You'd want to use the one that's lacking the normal. So you can see that I have that duplicate a normal node group for each one of these nodes here. Okay, let me just show you how that works very quickly. If we take Suzanne, now this Suzanne does have a normal map on it, and I applied kind of a rocky texture just so you can test this out. And here's the original composite material that has that normal map on it. If I take the normal output and I put it into the normal input here on my diffuse lighting, and then I take my color and I put it into the input there, you can see this is what the diffuse node looks like without the normal. This is just the world lighting, no shadow mask applied to it yet. And this is what it looks like with the normal applied to it. So you can see the bump map being applied here with those normals, and it affects the diffuse box map lighting that's in there. So the world, the scene lighting colors are being mapped onto this bump map, onto this normal map properly. Okay, now I might take that from there and put that into the shadow mask, and I would use this one down here that has the normal input, and I can take my normal from my original material and drop that in again. Again, you want to be consistent. You wouldn't want to put this into the one that doesn't have the normal, because the normal map should also affect the OpenGL light for the shadows. That would then look like this. So you can see that the shadow is being applied properly in a convincing way. Then I might, if I wanted to have specularity on this, I'm not sure it will look good, but we can try it. We'll take the material output from my shadow mask, drop that into the material in for specularity with the normal, and then I want to again drop my normal output from my material into the normal input, and that would look like this. So we can see that specularity out there, and it's applied properly to the bump map. Again, I'm not sure it looks really good in this particular case, but you certainly can do it. Let's get rid of that specularity. And then, lastly, we have the ambient occlusion mask. Now, the ambient occlusion mask will not work with the normals because you can't really bake an ambient occlusion layer using normals very well. Okay, normals are an artificial, bump maps are an artificial representation of relief. So the ambient occlusion mask is applied to the geometry itself, and it really works out fine. You don't really notice that there's a discrepancy there, but there's only one ambient occlusion mask node group. So we would drop the output from our shadow mask normal node group into the ambient occlusion mask with our ambient occlusion layer applied, and in this case the ambient occlusion layer is a vertex paint layer. Looks like that. So this is not actually a texture, it's just a baked vertex paint layer, and then we'll drop that into the output, and there you have your final output with a normal bump map applied, including the diffuse lighting as well as the shadow mask in a convincing way. So this is the whole getup here. You can download this and you can start playing around with it right away. I just want to show you a couple of other things here too. If we go to the camera view, I just want to show you that while this is not intended to be authentically physically based rendering in the sense that what you see in the viewport using this is what you get rendering, it actually will render using the internal render engine very similar to what you see here. Now I just need to explain though, the reason why it will is because it will use all of these shadeless material nodes that we have created. So it would make sense that it would render properly, but that's not really using the Blender internal materials, if you follow what I'm saying. It's really using our own materials. So just to, to demonstrate the idea, if I go to the render tab and I hit render, it will render this out, and you'll see this looks very, very similar to what we have here. It looks nearly identical. Now if I hit the OpenGL render button, you see in less than a second I get essentially the same image. So you can render internally and get the same results as what we're creating with our node groups. You can hit this button and snooze yourself away as that renders out, or you can just hit the OpenGL render button, which is the whole point of this file. Okay, so there you go, some relatively photorealistic world lighting applications here using these node groups. Now, how are we going to utilize this? How do we use this file? First, I want to show you kind of the consequences of using this file, and then we'll work our way through how we can import these very quickly, which is kind of a rerun of the previous tutorial, but I do want to try to do it quickly with this file, this particular one, so that there aren't any questions left out there unanswered. So very quickly, let me show you an example. This is an example file with a model in there. This is another one of Andrew Kramer's Star Wars pack models, and again, these are free, so go to the Video Copilot website. You can probably search for these models and download them, and this is using all of those node groups that we were just looking at. Now if we look at the water evaporator object, we look in here, you'll see I'm using the normal mapped examples here. Okay, I'm using the normal mapped examples because there was a normal map that came with this model, and I wanted to make use of all of that. Okay, so I just put the normal out from my shadeless texture. And this is again what the material would look like straight away if I take the output over here, drop it into our output over there. This is the shadeless material, okay, without any of the other layers. Now if we go to the material slot, you can see what's going on. I have my composite here where my node groups are set up. I have the shadeless material, and in that shadeless material I have the normal map set in there that the model came with, and the normal map is set to 1 on the geometry, so you do have to set this up like you normally would. But then the actual texture is shadeless. The whole material is shadeless. Okay, so that's coming into the composite, and that's the initial material that we're starting with. Then I created additional materials that deal just with the other maps that the model came with. So I have one here that is the reflective map. This is a map that maps out the reflective surfaces, or the parts that are supposed to be reflective on the model. And then another one that indicates where the specularity is supposed to occur. And this model did not come with an ambient occlusion pass. Some of the models in the pack do, but this one did not. So I baked my own. And then eventually I baked another one. This is actually a texture bake that has an ambient occlusion that's interacting with my ground plane here, so I could get that ambient occlusion on the bottom. So I did bake one pass here for that. Okay, so back to the composite layer. We have our shadeless material coming in right here. I have my normal map coming out, going to my diffuse lighting. So I went to my add option here, went to my group. You can see I've imported all of my node groups from my file, the file that I'm sharing with you, and I slapped in there the diffuse lighting normal. Put the normal in, put the material in, and that output looks like this. So you can see that my world lighting is being applied. And you can see the colors from the scene are being applied to the model. Then I took that into a mix node up here, and I brought in my reflection normal node group, and I put my normal output from my shadeless material into my reflection node, and that reflective surface looks like this. So this is the reflective surface, and you can see that that normal map is being applied. There's a bump map that is occurring here in my reflective surface. So it's reflecting everything from the scene. And what I did is I mixed my reflection, and I just used the defaults. I mixed my reflection node group with my diffuse lighting node group in a mix node, and for the factor I used my reflective map material input. So here's the material. I only needed the color because it's just a map. I set a stark curve on it. I added a color curve so I could really make the map kind of stand out. You can adjust the map using a curve. You could probably adjust the map using a ramp as well, a color ramp. But I wanted these whites to really stick out. So everything that's white is going to be more reflective. Everything that's dark or gray or black will not be as reflective. So that is the factor input, and this is what I ended up with. So now we can see the reflective surfaces from my plug-and-play node group for reflection and the plug-and-play node group for the diffuse lighting. Then the next thing we did is I applied to this a shadow mask. So I imported my shadow mask normal node group. I took the material out from that mix node into here, and again I dropped the normal output from the original shadeless material, and that looks like this. So you can see the shadow being applied, and it is using that normal map to apply the shadow, so there's a little bit of bump mapping going on there. It's really starting to look like it's in the scene. Then what I did is I brought that output down to a specularity node down here. So I brought my normal output from my original shadeless material. I brought the shadow mask input down here to the specularity. And that specularity output looks like this. So this is applying specularity all over. There is actually specular highlights all over the object. You can see even on the places that are not reflective. And then what I did is I brought that output up here to a mix node where I brought in the shadow mask output minus the specularity, and then I mixed them together using my specular map material. This is just standard compositing techniques. We're just compositing together our different textures on their isolated materials in order to get a good result. I applied a curve to my specular map just so I could again make those parts pop out really well. So this is what that map looks like. Oops. So this is the map. Anywhere where we see white, we'll see specular highlights. Anywhere where we see gray or black, we will not see as much. Black, we won't see any. So that is the factor input, mixing in the specular node group with the shadow mask node group minus specularity, and that output looks like this. So now we have specular highlights and reflectivity only in places where it's supposed to be. And you can really, I mean, these are really good maps. This is a high quality model with high quality textures. You can see it looks like there was, a metallic surfaces pitted and corroded and rusted there. So you still see places where there's some reflectivity and some specularity, but it's not all over. Okay. And then we took this output and I dropped it lastly into an ambient occlusion mask, which I imported from my file. So that ambient occlusion mask is using this ambient occlusion pass. And this is a baked texture that includes ambient occlusion from the ground plane for the scene. You could, you could bake this to a vertex color. It won't be nearly as clean as we looked at in the last tutorial, but you could do that. So this is kind of a higher resolution, and I set a curve on it just to make it a little bit more contrasted, to nuance it a little bit, bring out the whites. Anywhere we have white, we will see the texture, the material minus the shadow. Anywhere where we see the black, we'll apply a shadow input, and we run this through the pre-made ambient occlusion mask node group, and this is the final output. So there you have it. These are all plug and play node groups. You don't really have to do a whole lot with these to alter them. You can get into them and change some of the settings, but you shouldn't have to do very much of that. Also, the ground plane is very similar. The ground plane is just a texture I downloaded from textures.com. I made a normal map for this in GIMP. I fabricated a normal map and I loaded it into the texture, and I just followed the same procedure. So this is using all the world lighting and everything as well. The one difference for this, however, is that I used for my ambient occlusion pass, I didn't make an ambient occlusion bake texture. I just made a vertex paint layer bake. So you can see there's a little bit of blocky ambient occlusion down here generated from that vertex paint bake, and that's sufficient enough for this ground plane. So once I plug everything in together, this is what we get. And it's pretty passable. And I only used a couple of nodes here. I only imported my diffuse lighting node, my shadow mask node, and then the ambient occlusion mask. And that's all I needed in order to get this to look perfectly good inside of the scene. So this is the original output, shadeless. And then this is with all of our physically based coloring applied to it. And we go back to the camera view, this is what we have. And again, I can render this very, very quickly using the OpenGL render button, less than a second. Or, if you want to render this, from the internal render engine, you can go get yourself a cup of coffee and wait, several seconds for this to play out, and essentially it's identical. It's exactly the same thing. It really is no different one way or the other. So there you have it. That's how you can use this. Now, very quickly, importing. Let me just go through the process of importing these materials one more time just so you can see a couple of options for doing that. I want to quickly show you one other thing real quick, though. I want to go back to the original file, this scene here. What I did is I color-coded them so you could see them from this file, but I also did something else so you can play around with this file a little bit and change the settings or nuance them any way you want to. Any place where there would be a setting that you might be interested in changing, for example, in the reflection node group, if I tab into this, what I did is I took those adjustment nodes and I made them red so they would stand out to you. So any node that is an adjustment that would change the quality of the material in a way that you would want to is red. So here's a color ramp. Also, another thing I did is I removed the texture normal map that I had in there, and I replaced all of those with just normal dots. So Blender is actually doing all the computation for the normal maps. So there's no need to use those textures. It's one less thing that Blender has to try to process by using its own internal normal dots. So I did do that anywhere that is. So that's one less texture that had to be packed into this file. So anyway, here's this node. Let me just show you exactly how that would work. If I take this reflection node group and drop it over here, so here's the reflective surface by default. It has a bit of a Fresnel on it so that it's a little bit more reflective on the outside edge, a little bit more dull on the center. If I go into that node group, you can see that this red node with the ramp on it is the one that you would want to edit. The white color in this case would represent the highly reflective surface on the outside of the normal, whereas the darker color would be the diffuse surface in the center. So what you would do here is a couple of different things. You can move the sliders to change the Fresnel mapping, so you can tighten that up if you wish. You can also change the color. So for example, on the gray side here, if I make this black, it will make it very dull. Okay, it will go to that diffuse texture input. So I can roughen up my reflective surface by doing that. If I go to my white side and I do the same thing, I make this a little bit darker, you can see now this looks like a rough reflective material that is starting to pick up shadow. And you can still see the Fresnel effect of higher reflectivity on the outside edge, but I am editing the material using this slider. And then I can also tighten this up if I want to. If I bring this in, you can make it more reflective towards the center, or you can bring that diffuse out and make the Fresnel effect very, very tight on the outside. A lot of different ways that you can edit this. But anyway, I put that in there so that you would be able to edit these things and kind of nuance them any way that you wish. Unfortunately, I believe that when we import these materials, you won't get all this color coding. But it is in here for you to check out, at least in the main file. Now, another way to deal with this is that you could import your objects into this. If you know that you're going to be using this scene and this node setup, you could import your objects into this file. You could save this file as a separate file, a project file, import everything into here, and then you would have the color-coded references. Now, I would recommend that you don't do that because that's an easy way to really mess up a good file. You could always go download it again, but you probably want to avoid making any sorts of errors like that. So the better way is to actually import these node groups into a new project. So let's do that. We'll make a new project, and on this project we want to enable our GLSL shading. We'll set this to texture, get rid of our default cube. We're going to want to make a window down here for our node editor because we will need that eventually. We'll go to the camera view real quick just to see how things line up. We do not need this light. We're going to get rid of that. So we need to import a few things. We can append in or link in the material node groups themselves. Or, as I showed you in the 7th tutorial, the previous tutorial in the series, we can just bring in the object, that Suzanne, that has all of those node groups already connected to it. I kind of prefer to do that, but you can append materials if you want to, and let's just try to do that. Let's first append in our scene. So we'll go to the... let's find the file here. Viewport PBR nodes. And if you notice here, when we append, we have all of these options to choose from. We can go to the object selector here. One thing we're going to want to append in is we're going to want the light. And if we want to, we can append in the test. But I'll probably leave that out for the moment. We'll just append in the light. So now we have our sun lamp is in here. Let's just append in the materials and see what that looks like. So we'll go up here, File, Append, and if we go back up the chain here, we can come down to Node Tree, and you see that in our Node Tree options we have all of these included. So let's say I select the top one, and we'll hit Shift and just select all of these. And we'll hit Append from Library. And now what happens is that if we go to add, well, we need to add an object and a material first. Let's bring in just a Suzanne real quick. Object, monkey head, and we'll quickly add modifier. You know how this goes, and we want to make it smooth. And let's go to the material slot. We'll hit new material, and we'll hit make this one shadeless, and we'll call it comp, and we'll enable the nodes. Okay, so in here, what I would do is we can get rid of this material. We won't need it because we're going to be using node groups. Now I should be able to come down here to add and go to group, and I can see all of my node groups that I brought in. Okay, that's it. So let's say I want to use, we're not going to use a normal map, so we'll just bring in a diffuse lighting node, and you can see that the color codes that I put in there don't exist. So you're going to lose those whenever you link in. Okay. Now one neat thing about this, I believe that if I duplicate this, it makes a separate user. You want to make sure that you click whenever you change settings on this number. This is kind of basic Blender etiquette, because if you make a change in one, if I tab into this and I edit it in some way, I want to make sure it doesn't change everything. Okay, so just be aware of that. Let's put a color on this. We'll add in a input RGB. We'll just leave it on the default gray, drop that into the diffuse lighting, and we bring this out. And automatically it will apply my box maps and everything that I need. Okay. Now I'm not sure about the materials. This is why you might want to just import the Suzanne, append the Suzanne in rather than the material node tree. Let's add another material here and see what's available. It looks like we have everything. So one thing you'll want to do is you'll want to create a material slot for the diffuse, and you'll want to create a material slot for the reflection, because you'll want to be able to edit these if you want to change your environment. The next thing we want to do is we want our world to have our equirectangular triangle. So if I go to my world tab and I go to texture and I look at my options here, you can see I have my diffuse box map and I have my reflection box map. And I also have my noise texture that goes along with my node groups for the car paint node group, but I don't have my equirectangular image. So I could just open that up, or the other possibility is if we go back up here to append, I go back up my tree, I go to texture, I have some options in here. One of them is world map. So that's what I called it, was world map. And now if I append that from the library and I go back to my world textures, I can select world map, and there's my equirectangular image. Now I do need to still set this up, equirectangular, set it to horizon. Now the other option is that I can actually append the whole scene. That's another way to do it. I could just append the scene into this. So there's a lot of different options for bringing these materials into the environment here. Go back to my world button, hit real sky, and then in my display options I can hit world background, and now I've got everything there. Okay, so back to Suzanne. Back to my composite material. Let's say we want to get some shadow on here. We'll just add into it another group, which would be the shadow mask. I just drop it on, plug and play, there it is. And let's say we add in another, let's just be done with that. Now let's get an ambient occlusion mask in there. Let's add in another group. We'll go to the AO mask. We'll drop that in, and we'll quickly render out a vector paint ambient occlusion. Let's go to the UV maps here. We're going to create a UV map, tab out of it, and we'll go to our UV unwrap. We'll do a smart UV project real quick, and on top of that we'll add a vertex color layer. We'll call this AO. Now if you had an ambient occlusion pass, this is what you would import into it. You wouldn't be going through this, or you could bake one out if you wanted to. And then let's bake this. So we'll go to the render tab, down here to the bake setting. We'll put in a geometry node, put the vector color output out here, select our UV map, select the AO. And on bake, we're going to select ambient occlusion, normalized, bake to vertex color. We'll hit bake, and there's our layer. So we have an ambient occlusion layer. Now all I have to do is I drop this output into my AO map on the mask, and then I put my material out into the material in, and then the material out from the AO mask. And now I have ambient occlusion applied. So that's the way to do it with vertex paint, like we did in the previous tutorial. Again, you could just have a material that has that ambient occlusion mask on it, or you could just forego all of that and use the handy dandy ambient occlusion setting here for the screen space ambient occlusion. Now again, screen space ambient occlusion is very nice, except for the blockiness that it gives you in the render output. So you want to have, in order for it to look good, you need to have a very high resolution image, probably even bigger than full HD. You want to have your sample set up pretty high. You know, I put it kind of up there. And even then you're going to get a little bit of some artifacts around the edge. So those are all your different possibilities for ambient occlusion. Anyway, that's it. That's how you can do it. Or look back at tutorial number 7, where we just import the Suzanne monkey head and you get everything available to you there. And one last thing, very quickly, proof of concept. If I want to change my environment, I go to my diffuse material, I click on the texture. I need to create this because it was packed. I go here to my texture slot for my diffuse, and then I can go to my other world maps that I have. So let's say city sunset, select that diffuse, and we'll go to the reflection map. We're not really using it, but we'll do it anyway. And we'll go to city sunset, reflection, open that up, and we'll go to our world tab, texture, create that, and we'll go to our city sunset. We'll grab the equirectangular image. Here's our new situation. Now our OpenGL light is not set up properly, so we need to move that very quickly. So let's find our light and we'll rotate it. So that it's generally coming from the right direction. We can move it around. And I might increase my energy a little bit just to make it fit a little better. Give a little more stark contrast. It might be too much. And there you have it. So there's our new environment. Probably better if we add a little bit of a specularity. I could probably go into my diffuse map for this material to get a little bit of those oranges out. I could add a few adjustments to that. Let's quickly add a specularity map here. Group. And specularity. This is not using the normal because we don't need it. Throw that on. You can see some specular highlights now showing up. Again, I could go in there and edit those, change my Fresnel effect on that to make it work right. Let's see what the reflective material looks like. We'll import the reflection. So there's the reflective material. We could bring in our refraction material. And there's our refraction material as if it's a lens and we're looking through it. So plug and play, everything kind of works out pretty well. And there you have it. You would want to again set your OpenGL lights to best reflect your scene, but you should be able to, no matter what, once you get all of your node groups set up, you should be able to just change your diffuse, your reflections, and then your world map, equirectangular map, and you should be able to get a quick application of any new environment very quickly. So there you have it. Good luck with this file, and I hope you find this useful, and I wish all of you a Merry Christmas, early Merry Christmas, and I wish all of you happy blending.